Chapter 12, Section 4. Example: Customer segmentation. In this section, let's see an example of cluster analysis. We use a case of customer segmentation. Here, we use a dataset published in Kaggle. It consists of 200 supermarket customer data collected from information recorded in their members' cars. Using this dataset, we segment the customers into some clusters. This dataset contains 5 variables, but here we use only 3 of them: age, annual income, and spending score. These are the first 10 rows of this dataset. Here, we use only these 3 variables. They differ in units, so we need to standardize the data. And we input all these variables to develop a k-means clustering model. Clustering is a method of unsupervised learning, so we do not need to separate predictors and labels. And we do not need to split data into training set and test set. We develop an unsupervised model using the whole dataset at once. Here is basic steps to implement cluster analysis using k-means. First, inspect the dataset. In this phase, check the metadata, that is, data information that includes how the data was collected, what kind of variables and information are included in the dataset. Then, we implement exploratory data analysis. Second, we select the variables we use for clustering. We can select the variables based on our finding in EDA. Third, we implement necessary data preprocessing, such as missing value imputation, standardization, and so on. Clustering is unsupervised learning, so we do not need to split data into predictors and a label, nor into training set and test set. As the fourth step, we determine k-value using the elbow method. Next, we apply k-means clustering and assign clusters to each observation. Finally, we investigate clustering by aggregation, visualization, and so on. Using the elbow method, we can determine the k, the number of clusters. It often happens that the elbow points do not so clearly emerge. In such cases, we can try several alternative k's and see the clustering result of each case. Here, let's set k to 4. Then, we can create a count plot to show the distribution of clusters. As we can see, the largest cluster is 1, and the smallest is cluster 2. If we create box plots by clusters, the characteristics of each cluster becomes clearer. In this case, we create the clusters using 3 variables: age, annual income, and spending score. So, the box plots were created for those 3 variables. Cluster 0 mainly consists of 30s. Their income is high, and the spending amount is also high. So, the cluster 0 is high-income 30s with high consumption propensity. Cluster 1 mainly consists of middle and old ages. Their income and spending amount are relatively low, but it seems that spending is a little larger than their income. Cluster 2 include broad generations, but seems to mainly consist of middle ages. Their income is high, but the spending is the smallest. So it seems that Cluster 2 consists of high-income middle-agers with low consumption propensity. Cluster 3 mainly consists of young people. Their income level is low, but their spending is relatively large. So, Cluster 3 consists of low-income young people, relatively high in consumption propensity. Let's summarize the points in this chapter. Clustering is a type of unsupervised learning. It can find unknown patterns in data, so it is useful for us to implement group-by analysis in novel ways. Clustering algorithm makes clusters based on similarities between data points. Distance-based clustering quantifies similarities by distance. K-means clustering is a type of distance-based clustering that quantifies similarities using the Euclidean distance. In K-means clustering, analysts need to determine the number of clusters, and we should know that the clustering results can widely vary depending on the number of clusters we set by ourselves. Thank you for watching. Please thumbs up and subscribe to my channel.